This is the very first video number 1 for section 9.1. We're going to start section 9.1 with a review of Pythagorean theorem. Hopefully you have already watched that intro video, but if not, you'll probably still be okay. So Pythagorean theorem, it applies to a right triangle. And remember, a right triangle is like the one you have right here with the 90 degrees, and we'll just label that a right triangle. In a right triangle, the square, so remember that means to the second power, of the length of the hypotenuse. I meant to look up how to spell this before I did this video and I forgot. That's probably spelled wrong. But the square of the length of the hypotenuse is equal to the sum of the square of the lengths of the legs. Or a squared plus b squared equals c squared. Hopefully you remember this from geometry. So this is what it looks like. So this is a right triangle because it has the 90 degree. The A and B, remember, are what we call the legs. So the legs touch the 90 degree angle. The hypotenuse is directly across from the 90 degree angle. So legs touch the 90 degree angle. Hypotenuse does not touch the 90 degree angle. So the formula says if you take this length and square it and add it to this length and square it, it's going to be equal to the hypotenuse squared. So let's look at a couple examples. This is generally how they go. Use the Pythagorean theorem to find the missing side. That's usually what we're doing in a right triangle. Leave your answers in radical form. So let's look at this first one. Now, the first thing you want to do is figure out where your legs and your hypotenuse is. So here's my 90 degree angle. So this is a leg and this is a leg. So I'm going to label one leg A and one leg B. My hypotenuse is directly across from my 90 degree. I'm going to call that C. So remember, the formula is a squared plus b squared equals c squared. And in our case, a is 3. So I'm going to say 3 squared, or 3 to the second power, plus b, which in our case is 4, plus 4 squared, equals the side that we don't know is the hypotenuse. So you could call it x squared. You could even call it c squared. So now we're going to solve for x. So 3 to the second power is 9, plus 4 to the second power is 16, equals x squared. 9 plus 16 is 25, equals x squared. And then remember, when we have a second power, the way we undo a exponent is to use a root. So to undo a power of 2, we're going to use a root 2 or a square root. So I'm going to write this on a different line. So we are going to square root both sides. Radical or square root and power of 2 are inverse functions, so those undo each other. So I like to do that. So that leaves x. The square root of 25 is 5. Now, if you remember, normally when we are square rooting both sides, our answer is always plus or minus 5. And it is in this case also. However, when we're talking about the length of a side, it never makes sense to have a length that's negative. So we can just forget about the negative answer and just use the positive answer. And in all these problems, we are going to be talking about lengths, so we can just say that our answer is just the positive one. But I did want to point out that normally you would have the plus or minus. So the length of the missing side is 5. All right, let's look at another one. Now again, first thing you want to do is identify which are your legs and which is your hypotenuse, because it's the two legs that you add together and are equal to the hypotenuse squared. So here's my right angle. The two sides that are touching the right angle are these. So these are both legs, so I'm going to say, we'll call this one A, this one B, and this is C. Our formula again is A squared plus B squared equals C squared. So in our case, A is 7, so I have 7 squared plus the other leg is also 7 plus 7 squared equals the one we're solving for is x squared. 7 to the second power, or 7 squared, is 49, plus 7 to the second power is 49 equals x squared. 49 plus 49, if you don't know, grab your handy dandy calculator. 98. 98 equals x squared. Now I'm thinking to myself, over here I knew 25 was a perfect square. I'm thinking to myself that 98 is not a perfect square, so I'm just going to punch it in the calculator and double check. So I get a decimal. Now if you notice up here, the direction said leave your answer in radical form, so that radical is a square root. So we don't want to write the decimal equivalent of this. What we want to do is, we're still squaring both sides. We have to get rid of that second power. So what we're going to be left with is x is equal to the square root of 98. So when it says leave it in radical form, we're not going to put down that decimal answer. We're just going to leave it as a radical. All right, let's do another. First thing you want to do is find your right angle. Here's my right angle, and the two sides that touch my right angles are my legs. Doesn't matter which one you call A and which one you call B. I'm just going to do that. The other side is the hypotenuse, and remember it's always directly across from the right angle, so this will be your C. So A squared plus B squared equals C squared. So A, you'll notice this time our leg is our unknown. So A squared, or we'll call it x squared, so it matches our triangle, is what we're solving for. B is 20 plus 20 to the second power equals C is 29. 29 to the second power. So I have x squared plus 20 squared is 400 equals, I do not know what 29 squared is, so 29 squared is 841. So I want to isolate the x all by itself on one side of the equal sign. So to undo plus 400, I'm going to subtract 400 from both sides. Here's a little tip. Actually, I was going to use that 841. That was still in my calculator. So I'm doing 841 minus 400. I was going to tell you, if that 841 is still in your calculator, just take your calculator and hit minus 400. So 400 minus 400 is 0. That's gone. I'm left with x squared on that side of the equal sign and 441 here. Now I'm going to check to see if that 441 is a perfect square. So I'm using my square root. And what's the number I'm checking? 441. Oh, that is a perfect square. It's 21. So when I square root both sides, I get x equals, remember those undo each other, x equals 21. Hey, I learned a new perfect square today. I did not know that 441 was a perfect square. Okay, one more. Again, find your right angle, the two sides that touch it. I'm going to call my A and my B. The other side I'm going to call my C. So a squared, in this case, a is our unknown, so I'm going to say x squared plus b squared equals, oops, I didn't mean to write b there. I meant to write 8 there. Good thing it's easy to turn the b into an 8. Equals 16 squared. X squared plus 8 squared is 64. 8 times 8 is 64. 16 squared, ooh, don't know that one. I think I know it. Nope, I was wrong. 256. 256. To get x alone, I'm going to subtract 64 from both sides of the equal sign. I'm going to have x squared equals 256 minus 64 is 192. And to get rid of that second power, I'm going to square root both sides. So I'm going to have x equals the square root of 192. I also do not know if that is a perfect square, so I'm going to check that. It is not. So I'm just going to leave it in the radical. Okay. That, I believe, is it. The next two are these your turns. So I think I'm going to end this video here. I'm going to, in the next video, give you the answers for the your turns, so you should have those done by then. And we'll go over these 2 word problems.